Let's look at the statement not in the parentheses z is equal to 10 and x is greater than 5, and then or x is greater than 5. Let's see if we can simplify that using any of the techniques that we've found using truth tables. I think I see two simple statements there. Let's let P be the statement z equals 10. Let's let Q be the statement x is greater than 5. Okay, then I can symbolize this as not, then in parentheses P, which is z is equal to 10, our symbol for and then Q is x is greater than 5. Our symbol for or, and then x is greater than 5 again is Q. Let's make the truth table for that to see what happens. So I have P, Q, so I know I'll need 4 rows. Under Q, I'll do true, false, true, false. Under P, I will do true, true, false, false. Now, I'm going to need the column for P and Q. It is not true that P and Q. And then it's not true that P and Q or Q. Okay, so my standard table for P and Q is only true when they're both true. So true, false, false, false. The negation of that, false, true, true, true. And then I need to OR this with Q, or so it appears. Let me double check up here. Yes, indeed, Q is what I'm ORing that with. So I want this or Q, so false or true is true, true or false is true, true or true is true, true or false is true. So this statement that we have is a tautology. This is always true. Now, depending on what programming language I'm working in, and depending on what the context is here, I can either replace this whole thing with just true. I could replace it with something simple like x equals 5, or x is not equal to 5. If this was an if statement that I was only running when that was true, I could just get rid of the if statement because I'm going to run that code no matter what. But regardless, recognizing that this thing is always true should help make it easier for me to simplify my program in some way.